Okay, so let's try the next coding exercise. So open the leetcode.com and go to the problem section, and in the search question, search network delay time, and there is a question number 743. It's come under the medium category, so we will try to solve this. So click on it. Okay, so let's read the question. So the question is, you are given a network of n nodes. So there are some number of nodes given n. All right, and then labeled from 1 to n. So let's suppose if 4 nodes are given, so the node number should be 1 2 3 4. If 5 nodes are given, then 1 2 3 4 5. And there is a network means like few nodes are connected, few nodes may or may not be connected with each other. All right, so you are also given times. So what is times? A time is a list of travel time as directed edges. So these are the directed one. Directed means there is a direction. Okay, two is pointing to one. Right. So we have some array is given. So this array is given times, and this array suggested us uh, the travel times as directed edges. So as an example, so if there is an array, so the element of array contains these three elements, a tuple. And what tuple denotes? U means first node, V means second node, W means uh, the time it will take to reach from 2 to 1. So, okay. So where U is the source node, V is the target node, W is the time it will take to travel the signal from source to target. We will send a signal from a given node. Okay, so there should be some node K. So let's suppose K is 1 or K is 2 or K is 3 or K is 4, whatever the node the examiner can say. So any node can be given. We need to return the minimum time it takes for all the n nodes to receive the signal. If it is possible, then for all the node, then to receive the signal. Uh, if it is impossible, then we have to return minus one. Otherwise, we have to return the uh, that is that like minimum time travel to take the signal. Okay, so let's understand the question. So by looking the examples first. So let's suppose this is the example. So we have times array given. So in the times array, so there is a tuple, or you can say like there is a list. So the list is source and then destination. So 2 to 1. So 2 to 1. And how much time it is taking? 1. Then 2 to 3. 2 to 3. How much time taking is 1. Then 3 to 4. How much time taking is 1. Okay, so and k n is 4, so the nodes labeled as 1 2 3 4, and k is 2. K means source node, so we have to check whether from the source 2 can we send the signal to all the nodes. If not, then just return minus 1. If yes, all right, if yes, then tell us the time, the minimum time in which all the nodes should get the like receive the signal. So let's suppose if 2 send the signal to 1, it is taking 1. If 2 send the signal to 3, it is taking 1. If 2 send the signal to 4, it is taking 2. Like 1 plus 1, 2, like 2 second, or you can say it's a kind of second or minute. All right. So answer should be 2. Correct. So we need to solve this. So this is a kind of a graph question. So when you see a network of nodes, then consider a kind of a graph. So let's go to the whiteboard and let's try to look the further question. So we will take this is a bigger example. So we have some array is given, times array. So this is time array given, and in the times array, what I told you that array consists of again a further array. All right, so a list of list basically, and that list of list donate is equal to source node, destination node, and the time it will take on. So let me rub this. So first is 1. So 1 to 2 is one node, and how much time it is taking? 1. 1 to 3 is also there is a connection. uh, because this graph is not given to us, we have given only the array. So we have to to solve this question, we have to understand how we are going to solve this question to write the code, right? So that's why we draw these graphs. But how we draw this graph? We know U is the source node, V is the target node, and W is a time. So one is the source node one. One to two, there is a connection, and how much time? One. Okay. Then one to three. One to three is there is a connection. How much time? Two. Two to four, there is a connection. How much time? Four. Two to five, there is a connection. How much time? Five. Three to five, there is a connection. How much time? Three. Okay. And we have given a start node. Let's suppose we have given a start number of nodes here is 1, 2, 3, 4, 5. So we have given five nodes, right? So n is five. So this n is five. This times the function is accepting time. So this time is given this one. Okay. Then k. So let's suppose in this example k is one, right? So this is the start node. So we have to calculate the time, you can say minimum time, or the time when all the nodes will get the uh, receive the signal. So let's suppose if one send the signal to two, then it will take only 1 second. If one send the signal to three, it will take 2 seconds, right? So if one send the, so if we just consider only this area, if we just consider only this area, let's suppose only this is the graph. So what will be the answer? The answer is two, because if we take only 1 minute, within 1 minute, three is not receiving the signal. So we have to calculate the time in which all the nodes receive the signal. So the time is two. So the question says minimum time, right? But like output is output is, you can say, is a kind of a maximum. Like if two nodes is receiving in 1 minute and three node receiving in 2 minutes. So what is the maximum time after one and two? Then two is the answer, because we need to calculate the time when all the nodes receive the signal. But why it is called as a minimum? Because we have to find a way. Is there any other way? Like maybe, okay, let's suppose, okay, so one to two is a one node which take 1 minute. One to three is a one node which take 2 minutes. Then two to four is taking 4 minutes. So so one to four, how much time it is taking? One plus four, five. All right. So then two to five, there is a one node. So one to five, how much time it is taking? One to five, this is the connection. This is the connection. I like one to five. So five plus one, six. So this is taking 6 minutes. But one to five, this is also the connection. All right. So how much time it is taking? Three plus two, five. So that's why it is called as a like minimum. So to reach the node number five, whether we have to count six or whether we count five, so we will treat as a five. So from one to two, one. So one to three, two. So one to four, five, right? And one to five, one to five. So there are two options: one six and one is five, right? So we have to take the minimum one five. So now, so it means one to five is also five. So what is the minimum time? Minimum means what is the time in which all the nodes should get the signal, get receive the signal. So which is the 5 minute, or you can say the 5 second, whatever the digit or unit. All right, so 5 second. So this is the answer. Okay, so how we are going to solve this question? All right, so let me rub this 1 minute. So this is like a very easy question and not a complicated question. Generally, this question can be solved using the Dijkastra algorithm, but I'm not going to do with the Dijkastra algorithm. Let's suppose, because if the examiner give us the question, how we are going to know which algorithm is going to implement? Even if we know which algorithm is going to implement, we should know that algorithm. All right. So I will consider this as a graph question. That's it. And we know in the graph we have the two methods, that the DFS and the BFS, that the depth first search and the breadth first search. So we are going to solve using that method. Okay. So okay. So how we are going to calculate? So what we have to do is, like, we have like we know there are five nodes, 1 2 3 4 5, like that. If we know all the times it is taking from start to all the nodes, then we can get the maximum time, right? So let's suppose we can create some array. We can create some array, and if we know from 1 to 1 how much time it is taking, from 1 to 2 how much time is taking, from 1 to 4 how much time is taking, from 1 to 3 how much time is taking, from 1 to 5 how much time is taking. If we know this array, so this array, only this array, if we know this array, then what we have to just return, we have to return the max of this array. Because let's suppose if 1 to 2 is 1, 1 to 2 is 1, 1 to 1 0, 1 to 3 2, 1 to 4 5, 1 to 5 6 or 5, but we will consider 5. So what is the max? So max is 5. All right, so we have to return. But how we are going to generate this array? All right, how we are going to generate this array? Because this is a graph. So for the graph we have to traverse through all the nodes. All right, so to traverse through all the nodes, we have the breadth first search or the depth first search algorithm. Correct. So here we are going to implement the like a BFS. Correct. To implement the BFS, we have to create some adjacency like a matrix, or you can say list. Adjacency list means like so like we have like five nodes, right? So one is pointing to what? So one is pointing to 2 and weight is 1. One is pointing to 3 and weight is 1. So one is a key and these are the values. These are the values. Or you can say like we can put in the list. So one is a key and these are the value. 2, if 2 is the node, 2 is pointing to 4, 2 is pointing to 5. So 2 is pointing to 4, 2 is pointing to 5, and if 2 is pointing to 4, then what is the weight 4? If 2 is pointing to 5, then what is the weight 5? Okay, done. For the 3, for the 3, 3 is pointing to 5, and what is the weight 3? So we have to create this. And why we have to create this? Like, what is the use? Like, if we not create this, why we have to create this? Because we have to traverse the we have to traverse the like this graph. Because to solve that question, BFS or DFS, any method, we need this adjacency matrix, because in the graph question we need that. So that's why we created this. Okay, once we know this, then we have to just implement the BFS. So how to implement the BFS? What we will do is, we will take a queue. We will take a queue, that is the empty queue. And what is the property of the empty like queue? Is first in first out. Whoever will come first, that will remove first. All right, okay, FIFO, that is first in first out. So what we will do, we have to start from the node number 1. So what we can do is, within the queue we are going to insert a tuple. And tuple contains node, that is the starting node, and the time, how much time it will take to reach to that node. So we know from 1 to 1, if source is same, destination same, then it takes 0 second. Then in the starting, in the queue, we are just putting this 1 0. Okay, then what next? How we are going to check how much time it is taking to 2, how much time it is taking 3, how much time taking 4, how much time it is taking to till 5. So what we will do is, we know 1 is pointing to this node and this node. All right, so first we are going to pop this node, because 1 is done, right? Okay, before doing that, because we know from 1 to 1 it is taking 0, that we know. So that we are going to put here, so within this array, because we know we have to calculate the minimum time. And how you are going to calculate the minimum? If we know from the starting to all the edges, if we know how much time 1 is taking to 2, how much time 1 is taking to 3, how much time taking to 1 is to 1 to 5, 1 to 5 and 1 to 4, then we are going to store in some array. And then we are get the max of that array. So we have like initialize some array with some maximum value, and maximum is like infinity. I will also like tell you why we take this 0 in starting, because they have said like the node numbers are 1 2 3 4 5, so it doesn't matter even you took 0 1 2 3 4, just to make our code easy. Otherwise we have to put n minus 1 or something just to make our easy. uh even though like we are going to like work with this part only. Okay, so let me remove some markers, just a second. Okay, so what we have to do, so we put like 1 0 1 0 in our queue, so we put 1 0 in our queue, right? And we pop it, so we pop, so we put this and we pop it, so we get the node, we get the time. What is the time? The time taken from 1 to 1, that is the time. Then we will check this time with this array. So if the time at node 1, so if time at node 1, which is infinity, and which is this, if it is greater than this time 0, then we are going to put 0. So we have replaced this with 0. Right? So now we have pop 1 0. Now we will check in the adjacency list. Is 1 is connecting with any node? Yes, 1 is connecting with 2 and 1 is connecting with 3. Then we are going to append all the elements 2 1 3 2. But what we will do is, now we are not going to append 1 and 2. What we are going to append, because we are on the node 2 and we are no, on the node 3, right? But how much time it is taking to reach till node 2 and till node 3? So the time start is taking to till 0, then to till 2, or till 3, right? So we are adding this time 0 plus 1 and 0 plus 2, right? So we are adding 0 like the earlier time and the new time, which is already given to us. Okay, let me re-explain, because if we explain the logic na, then to write the code is like it's very 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 easy, just believe me. All right, so we pop one and we are going to put it like we are going to check this addition matrix. So in the addition matrix we have the 2 and 3, so we are going to like in the queue we are going to append 2 and 3, but we are going to append with some time. And what is the time? The time this is given plus the time start node take till 1. So till 1 is 0 0 plus 1 and 0 plus 2. Okay, then in the queue we are going to pop 2, so we are going to pop 2, then we are going to pop 2, then we go to the node 2 and we go to the time 1. So we know start is taking only 1 minute or 1 second till node 2. Then we are going to check in this array. So is 1 is less than this infinity? Yes. Then we are going to put this one here. Okay. Then in the then we are going to check. Okay, what are the elements for the like uh, in the adjacency list for the two? So 4 and 4. So we are going to put 4 and 5, but we are not going to put this time. We are not going to put this time. We are not going to put this time. We are going to put the time it is taking till 2 plus 4, because that's why it is taking till 2 and plus 4. So 4 plus 1, 5. All right. So we are going to put 4 like 5 plus 5 plus 5 like this. Okay. So this is we are putting. Now we are going to pop 3. So we are going to pop 3. So now 3 is removed. So what is the time? 2. So we will check. Okay, we will check here in this array at place 3, it's infinity, but it is taking 2. So 2 is minimum, so we are going to put 2 here. Okay, then we are check in the adjacent series, is 3 is connected with any element? Yes. So 3 is connected with 5 3, but we are not going to store 3, we are going to store the time it reached till 3 plus this 3. So 5 plus 2 plus 3, because we already get the time here na. So 5 plus 2 plus 3. Now we are getting like in within the queue, these are the 3 elements. So these are the 3 elements. Now we are going to pop 4. So we are going to pop 4. So the time is 5. So we are going to put in place of infinity in place of 5, right? Because 5 is less than infinity. Now within the queue, so these are the elements, and we will check in the adjacency list. So in the adjacency list, there is nothing like 4 is not connecting with anyone else. So if 4 is not connecting with anyone else, then we are not going to like do anything. Then in the like queue, we have 5 and 5. Then we will check this first 5. So first 5, the value is 6. So is 6 less than this infinity? Yes. So we are going to put here. All right. So then we are going to remove this. And then in the queue, only this is left, 5 plus 2 plus 3. Then we are going to check uh, whether this 5 is less than 6. Yes, this 5 is less than 6. So we are going to remove this and we are going to put this. So at the end, this is the final matrix. So 0, 0, 0 plus 1 plus 2 and 5. And we are going to return the max of that. And that is our answer. All right. So let's try to implement like in our Python code. And it's very easy. So let me clear that. Like whatever like we did in this graph, na, same to same, each and every step we are going to follow. Okay, so what is the first step? First step is whatever the times is given to us. So this time is given to us. We are going to create this one. All right, so let's try to create that. Okay, so what we have to do, we have to create this adjacency list. Right, so we have to create the adjacency list, which is a dictionary. So it's a key value column. So default dict list. So let me import from collection. You are like you can do only like this as well, or that is like it's up to you. I am taking default dict so that I don't need to check like if the element exists or not, right? So by default like there should be list in that, right? So now what next? So I need to loop on this. All right, so I need to loop on this because this is going to tell whether one is connected with 2 or one is connected with 3. So now I need to loop on this. So for item in times array. Okay, for item in times array. So first I get this item. All right, first I get this item. So in this item, we know the first element is the node, second element is the connecting node, and third element is the weight. So what we have to do? So first element should be the key, and the rest two should be the as an like the value which we need to like attach. So what I need to do in the adjacency list, right? In the adjacency list, 1 minute. So in the adjacency list, what we have to do, we are looping on this array. Fine, we are looping on this array. So we have to store the key. So key should be 1. So how you are going to key? So item of 0 dot append. What we have to append? We have to append item of 1 and item of 2. We have to append item of 1 comma item of 2. That's it. Now at the end we are going to get this matrix, right? So we have looped okay, sorry. So we have looped this. Okay, so now what next? So this part is done. This part is done because this is required for the like our to traverse the graph for the BFS algorithm. So that's why we created the adjacency list. So adjacency list has been created. So now what next? So we have to like uh, like perform the BFS algorithm, and BFS algorithm is going to like create this dictionary, not dictionary, uh, this list, and then we are going to return some output. All right, so let's do that. So let's pause. It is going to return the minimum delay time and self dot BFS. All right. So we are going to call this some function self.bfs. We are going to write that function, and then we are going to return the minimum delay time. That's it. Okay. Yeah. All right. So now we have to write this function. So let's write this function. Def bfs self. Okay. Now what this like a graph will take. It will take the starting node. It will lead this adjacency list. All right, and it will also need the number of nodes. So everything it will need. So we have to pass everything. So adjacency list we have to pass. We have to pass k. We have to pass n, k, where k is the start node, n is the number of node. So we have to pass the adjacency list, and k is the start node, and start node, and n is the total nodes. Total nodes. Fine. Okay. Now what we have to do? What next? We have to create this array, because this array we need to update, so we need some initial array. So let's take some arrays. What name should we give? Let's say delayed timer, something. Delayed timer. Okay. So we need this array. So the first element is 0, and the rest element should be updated with the infinity. So first element should be 0, and rest element updated with the infinity. Float of infinity, like, and multiply by total nodes. All right. So we are getting this array. Okay. Now what next? We have to take the queue as well. So let's take the queue as well. So queue is equal to, and queue is a kind of a list, and in the starting it should contain the start element 1, and it should contain the 0. Okay, so what is the start node, and it should contain the 0. Okay, now we have to now loop on the queue until queue should not be empty. So while queue, okay, first we have to pop the existing element. So let's pop queue dot pop the 0th element. Okay, what it will return? It will return the node, and it will return the time. It is going to return the node, it is going to return the time. All right. Then we are going to check this time with the time exists here. Then we are going to check if time is less than time exists at this node. Time exists at this node. Then what we have to do is we are going to update delay timer of node with the particular time. Okay, so that is also done. So we are going to so that is also done. So till that point we have updated 0. Or you can say we push this 1 0, we push this 1 0, and then we pop it, and then we found, okay, from starting to 1, from start node to 1, it will take 0 0 second, and this 0, but in our this array we set infinity, so we should 0 is less than infinity, so we have to update our this array. So we have updated this array. So till now our answer is like this only, till this point. So 0 0 infinity 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 infinity. Okay, so let's what next? Now we have to check, like, that particular node, which node number 1 is connected to what other nodes. So we have to loop on this adjacency list. Okay, so for next node, comma next time in adjacency list. Right, so we are going to loop on this. So first we get this, then we get this. Okay, so we have to push this into our queue. So we are going to push in this q dot append, and what we have to append? Next node plus time plus next time, because time means, because we have pop this, so time means the time it like the start node took to reach node number one. So this time plus this time, right? And this time plus this time, so we have to add that. So we are pushing that. So that's it. And after that, but we will get our delay timer. So our delay timer is going to update it, because we are running in a loop. Every time like q will be going to push and pop. Okay, so what next? Now we are going to check if, because like, okay, so there could be one condition. So let's suppose this is the graph, but there should be sixth node as well. So there should be node number six as well. But node number six is not connected uh, with any node. All right. So in this case, we are going to return -1. So in this case, we are going to return -1, because it says if it is impossible if it is impossible for the start node to send the signal to each and every node. So it is impossible for the node 1 to send the signal to the node 6. All right. So what we are going to do is we are going to return -1. So here, if it is node 6 as well, so here we are going to put node 6. All right. And here we are going to put infinity. And if it is node 6, it is never come into this loop, and it always remains infinity. So this value always remains infinity. Right. So the same thing we are going to check if max of, so because we have to return the max, if max of delayed timer, okay, so how we are going to check whether this is the infinity or not? If max of a delayed timer is equal to float of infinity, or you can say like less than float of infinity, it means there is no infinity. Then we are going to return the max of delayed timer. If there is an infinity, then we are going to return the -1. Right, so let's try to run it. So something is wrong. uh okay, so here should be adjacency list of a node. So our solution has been accepted, so let's try to submit it. Okay, so our solution has been accepted. We know uh it is taking a huge time. All right, but anyhow the solution has been accepted, and this is the easiest approach, which I found. There are many other approaches as well. Like we can use the priority queue, we can use the heap queue, or you can say the priority queue only. Heap queue is the priority queue only. So by using that approach, like you can decrease your time as well. Right, but this is found the easiest approach, which like we got to know, because otherwise we have to cramp the question. like uh, okay, we have to find the minimum shortest time. So okay, what is the algorithm to get the shortest time? Okay, that is the Dijkastra algorithm. And now we have to cramp the Dijkastra algorithm, so I don't want to do that. So I just want to do that, like, okay, this is the graph question, and how to do that graph question. That's it. So this is the graph question. So there are only two algorithms which exist in the graph question. One is the DFS and one is the BFS. Okay, so let's apply the BFS algorithm. And to apply the BFS algorithm, we need the adjacency list. So we created the adjacency list. Okay, then just we apply the BFS algorithm, and within the BFS algorithm, we put the first node, then we pop the first node, then we put the adjacency nodes. then we are going to pop the another node, then we are going to put their adjacency nodes. So that's it. And we know like we have to calculate the timer, like how much time. So to calculate the time, we should know like from node 1 how much time it take to 2, 3, 4, 5. So to store, we have to store those timings. To store those timings, we take some array that is about 0, 1, 2, 3, 4, 5. In the starting we are putting infinity, and as soon as like we are like traversing the graph, we are updating this array as well, and at the end we get this array and we are returning the output. But there should be one scenario where there should be some node and where like there is a, it is not possible to send the traffic. So let's suppose there is sixth node and that will remain always infinity. So we will check, okay, if all the if the maximum value is less than infinity, it means like there is no infinity, and then we are going to return the maximum, otherwise we are going to return the -1. So that's the easy question. You can also try that. Okay, so that's it. That's the end of the video. Thank you.